safety issue with regard to these tanks. So here's a guy, George Gibbs. He learned that he had a car with a frozen fuel line, and he knew a little bit about physics, so he decided to heat up the gasoline in his kitchen, burnt the kitchen down. Nobody was hurt, did $5,000 worth of damage. So know a little bit about science, but it's hard to make things foolproof. Then we go to Texas City, and I use this example a lot, particularly when I'm doing HAZOPs or talking to design engineers. If you don't know much about the incident, go on Wikipedia, read about it, learn from it. What they were doing was when you ask people what caused the incident, it was BP's lack of maintenance, operator training. There are a whole host of things, plus not having the people there physically located near the processing unit. But what people always seem to forget is the biggest cause of this incident was the design. You don't vent heavier than air hydrocarbons in a process plant. You put them in a flare. You burn them so they're no longer flammable, and this incident never would have happened. So this is probably just a brother of George Gibbs. Operators are doing this a lot in the wintertime when they're not meeting vapor pressure. Putting in a heated gun barrel tank or a VRT seems like a better way to go to me. But this just happened in Carnes, Texas this February. A hot oil truck caught the battery on fire. Don't know what the circumstances are, but it did say that the hot oil truck was servicing an oil tank. And you can see he's probably 20 feet away from the oil tanks that are fully engulfed. And he's got an open flame that he uses to heat the oil he circulates, and you can see the relief valve has gone off on the propane tank that's on the truck. I don't know if the tank levied, but again, you only have 15 minutes if the steel has direct impingement. So I looked up, and it was 43 degrees Fahrenheit the day before. I don't know if there were SIMOPs involved. It was the policy and procedure to shut down all other truck traffic loading and unloading. Was there a hot work permit, a JSA? Did the lease operator even bother to show up, or their operating instructions? A lot of times these people just show up and there's no controls. And unconventionals are really susceptible to this type of incident because they're spatially dispersed over a large area, 100 miles, 200 miles, and the company people rarely show up. The paperwork's done in a central office because it's more convenient. Some operators even have the folks write their own safe work plans, hot work permits, and that just shouldn't be acceptable. Again, I don't know what the details are, but I think the results kind of speak for themselves. So talk about vapor pressure. Sorry. And what some of the solutions are. There's also some tips of the month that I've included that Mahmoud wrote for vapor pressure correlations, and I have one from last year on infinite recycle. And there's also some additional reading in the tip of the month that are two real good articles on processing unconventional crudes. So I want to switch gears to the fire tube failure. So what's going on? Well, there's two failure modes that people are seeing. One is flame lick occurring here, and I believe one of the causes for this is it's real windy in areas that this is occurring, and the wind creates a venturi and causes the end of the flame to move around. But it's just like a blowtorch, and it causes the steel from the inside to weaken. The other thing that happens is you get scale on the outside. It increases the thermal resistance, and the metal gets hotter. And so that's a heater treater that's been involved in a fire. And unfortunately, these aren't real rare. This one's one that's nicely atomized before ignition. I don't know if it ever ignited, but you can see it's always the bottom section where the flame is, and it's always in the 12 o'clock position. Well, if you don't know how to fix things, what you can do is look to how other things are done. In burners and plants, they use a ceramic refractory, and you could take just a small section or tube of a continuous shell and slide it into the fire tube. It might only have to be half an inch thick piece of ceramic. The flame, once it hits the ceramic can stand the direct flame impingement, and it knocks off maybe 200 to 400 degrees before it hits the steel. So you don't have direct contact of the steel with the flame. So I've talked before about how to become an expert, and you can use one Petro or talk to people, but if you put in heater treater fire tube failures, two papers come up. It's not unconventional. They're polymer flood, which has its own issues, some of the worst emulsions in the world. But they have a solution for the burner tube fire failures that I'll show you, and they've written a couple of papers. If you're having failures, go ahead and give David a call. I haven't spoken to him, but the vendor I'm going to show you and David have written like 2 or 3 papers. It's real hard in companies to publish. David's done it a couple of times, and even just contacting him, you may hear stories, and you're talking to somebody who's been where you've been and solved the problem, and you'll instantly become an expert on fixing this problem. And I'm sure somebody who goes to all the trouble to communicate would be flattered and like you to communicate with them. Again, it's the rat in the maze going for the cheese, making you more effective to get to solutions with the best available knowledge and best practices. So what it is a ceramic tube that the fire goes on the inside. It has a small blower, but what it does is it prevents direct impingement on the side. That's what the Flux burner looks like, and the small burner. So you don't have to worry about the impacts of wind. And that's from the vendor to show how you get radiant and convective heat off the ceramic, and a very distributed heating of the fire tube. Another thing people have gone to are indirect bath heaters using the glycol. That solves the scale problem with the salt and whatnot, but it doesn't solve the problem of burn through. So when the burn through occurs, you'll be having a failure on the indirect heater. So I mentioned this tool, the last lunch and learn we had. It's free. It's from thinkreliability.com, and they sell, they give the tool away for free, and they sell workshops. But I just wanted to show you how to use it for burner tube failures, and also what I think about when I'm doing a root cause failure analysis. So in this particular incident, an operator in North Dakota had 60 burner tube failures in 1 year, and it cost about $20 million. So that's what we're trying to fix. And so you have fires and safety and asset. It's to use the 5 whys, and as you move to the right, you ask why did it happen or what it was caused by. So you had loss of containment caused by fire, you had a hole, and then the pink boxes you put in evidence. Why did you have a hole? You had metal failure, metal creep. The green boxes you put are solutions. So you had flame lick. Higher heating value, I was showing you that might have some kind of impact in it. If you need information, you can put a yellow box in. I don't really think it's an influence, because I very rarely see these in operation where they're smoking, where they're having problems with handling very rich gas. And then you have evidence of external scale and external corrosion, and then the solutions there. So it's a very fast way of using this tool for brainstorming and coming up with a real good cause map. The things, everybody has all kinds of reasons why things fail. So Heinz Bloch, who's worked for Exxon, he's been an expert in reliability in facilities for refineries and plants, and also for upstream. Heinz will tell you, bottom line, whenever you're looking at anything that's mechanically failed, it failed because of FRETT, F-R-E-T-T. So that's force, reactive environment or corrosion, time, infant mortality, old age, and then temperature. So all things mechanical that break are caused by FRETT. So you can use that as a lens when you're looking at a failure. The other thing to look at is he says all mechanical failure causes fall into these 7 buckets. Faulty design, material defects, fabrication or processing errors, which would probably come out in infant mortality, installation defects, improper operation. And so I use these when I'm looking at FRETT and looking for causes. So if you apply that to the cause map I just showed you, FRETT fits perfectly. It was a faulty design, the T's are temperature, and the corrosion was reactive environment. It's just a way to get to causes and solutions faster. He's also got a great book that I'd encourage you to buy, and it covers all kinds of equipment that we use, compressors, generators, but this one's for centrifugal pumps. And you enter it through the symptoms, like if the pump's cavitating, it'll tell you what the #1 reasons are for causing that. So you go through and you look at for insufficient capacity or no liquid delivery, and you can verify that those aren't issues or they are issues. There's two, and the reason these charts are great, and Taproot provides something from Heinz, it's called Equifactor, but they're the same charts. You can run a company where your operators have these, so you can have a culture where engineering gets a call, the pump's broken, doesn't work. Or you can have a culture where the ops calls engineering and said, we've looked at the 21 reasons why a centrifugal pump doesn't work. We think it might be this, what do you think it is? And you'll get to the solutions faster. You're not having to guess on what the problems are. You've got a checklist when you go to the field to resolve the issue and correct it. And the faster you correct the issue, the more money you're going to make. So that's the boneyard up in North Dakota of all the burnt out fire tubes from one operator. And that's just not a good day. So what I've done too, just to show you, is these are all the files that I put on the Dropbox. So there's some Excel tools and some files, the civil manuals and some videos. These are the 2 presentations. Got the tips of the month that I referenced in here, and then I also put in the Unison models as well as the PDFs from the report outs. And then in Think Reliability, I downloaded a bunch of the YouTube videos that show you how to use the tools and how to do root cause mapping. And if you sign up for them, they're kind of cool. They'll give you monthly or anytime there's a failure, they'll apply their technique to why the Titanic happened, or why Macondo happened, or why they were in a gun shooting, and look for solutions. And then I've also included a copy of the cause map that I showed you. So appreciate your time and attention. Learn from mistakes that I've made. I hope that you use these solutions to make your company more money and safer. So anyway, it's been a pleasure talking to you. We can go and answer some questions, but I'd encourage you to contact me if you have questions about anything in the presentation, or if you just have questions, career questions on the oil and gas industry. And again, thank you so much.